Hey everyone, Anthony here today, and we're going to look at list comprehensions. So this is a little bit more classic Python stuff, so it's going to be, I guess, technical, but hopefully out of it, you'll be able to read people's code a little bit more fluently and also know how to use this for your own fun and profit. The other thing I'd also like to get out of this is for you to laugh at me quite hilariously when I tell you that this is now the third recording, of which the first two I managed to stuff up first by not turning on the microphone, and the second one by having really, really bad feedback, which meant that I can't use any of the footage. Awesome fun. But getting stuck into it, you'll see on screen here something from the previous video. So I left this list comprehension general format here. All right, don't worry about it, but I'll use that as a reference. It is pretty much, if you keep an eye on the pink highlighted stuff here, it won't change much, if at all, right? So there's a very particular structure, and we're just going to go through it. We will start with numbers to make life a little bit easier for ourselves, right? So here's some numbers I've typed up 3 times now. The first thing we're going to do is take the idea of taking this list and just filtering it down. So let's put this down here, filter, right? So we want to filter this to just, I guess, let's call it big numbers, big number, right? And we're going to apply a rule that says if the number is bigger than 30, we want to keep it, otherwise, don't care. So this could be, I don't know, likes on a video, hottest pixel, whatever. So 10 is not bigger than 30. 14 is not bigger than 30, 18 is not bigger than 30, 91 is, so let's keep it. 50 is bigger than 30, we'll keep it. 15 isn't, 33 is. So we've done a very simple filter operation here. All right, importantly, we've taken everything that we had to start with, and we've thrown away things that don't match our criteria. We haven't manufactured any new numbers out of anywhere, and we haven't modified the original set. So that's the first 2 big concepts to look at here. We're not changing the original, and we're not adding new things to it. We can only shrink the list. So let's do this in Nuke using groups, classes. So I'll throw down a couple here. Grades, dots, roto, paint, roto, blur, transform, you know, the usual suspects. All right, I'm going to grab a small selection of them, and then we're going to do this in the script editor using a loop, because as you saw, we went through left to right, we just did a loop. Okay, so Nuke selects, so let's start with nodes equals Nuke's selected nodes. So we selected them, and I'll just indent this out a little bit just so it's super visible. And then we want to say, let's just get the, actually let's make it a little bit, yeah, let's make this a bit more painful. That one, selected nodes, and let's just get the roto paint nodes. So there's 3 of them. These guys here, 1, 2, and 3. So roto paints. Okay, and we want a list of roto paint nodes out of it. Now, if we start like this, then okay, we start. Now let's fill this list up using a loop. For node in nodes, if the node.class equals roto paint, then we just add it to the list. Roto paints append the node. All right. Oh god, let's get the selection here. Done. Easy. We should see 3 nodes come out. Yes, 3. 1, 3, 2. Ordering, not important. We've got 3 roto paints. That is basically a filtering exercise. Now, let's rewrite that using a list comprehension style. All right. So, using a list comprehension, we say roto paints, roto patterns, no, paints, they're not roto skates, paints. All right. Node for node in nodes, if node class equals paint. And we're done. All right. And you can see how easy that was to write and how easy it was to actually say out loud as I went left to right. Now, I'll point out some differences. First of all, the loop approach has 3 lines to it, and you needed to do this one. So it actually has 4. Right. Less lines is not necessarily a bad thing, but it does incur, at least for me, a slight mental load as I sort of just go, all right, so I've done something here. Okay, I'm on a loop. I'm testing everything. And what am I? Oh, okay, I'm just adding it to the list. So I actually have to hold multiple things in my mind at one go, because, for example, I might not add them to the list. I might do something else with it. You know, be like, let's just comment that. It could be, it's append the number 1. I don't know why you'd do that, but you could append something like you could do anything you want here is the important takeaway. This loop construct is incredibly powerful. You can do anything you want. You can do many things. You can do, I don't know, more work, even more, right? Whereas this here is a little bit more constrained. You can only really do one thing. We could do 2 things. We'll get into the expression in a bit, but we're basically taking a list and we're shrinking it down. So it's very tight and very compact. Right? So it's a very, at least for me, again, this is the philosophical angle of it. It's a very clear description of what I want to do if I want to filter a list down. So it's just like, all right, I see a list comprehension. Okay, cool. You must be making it smaller. Done. I don't have to think. There's no other side effects occurring here. I just want to make it smaller. And that's sort of the advantage of this structure for me. It's very clear, it's elegant about what you're trying to achieve. And I'd make a comparison to, I mean, you could do it with roto paint. Technically, you could just put the roto paint wherever you want to roto. I mean, you could, but a roto paint to me screams out you're probably expecting to paint something. A roto is, I'm doing splines. I'm cutting out stuff. Same thing with merge and a channel merge. So same kind of idea. For me, when I used to comp a little bit, I don't really do that much anymore, unfortunately, but a merge node to me is about pixel color operations. I'm making my merge, I'm making my comp here. Channel merge, on the other hand, to me is less about making the comp, and it's more about, I would use them traditionally to muck around with my mats or something. So I'd blend my alphas together using the union, or I'd like, because I'm a technical operator, I tend to think in terms of like Boolean maths and all sorts of assembly. But I would keep these 2 separated. I know I could use a merge for all these things, but I would keep them separated because then I could look at my script a bit later and just go, channel merge. Anthony says channel merge, therefore Anthony means that he's dealing with alphas only, or he's dealing with data, or he's dealing with a map, like a DI mat or something. So I would reduce some of that mental load. And that's the same concept I use here with list comprehensions. And I suspect people will do that as well. It's just a way to express the thing they're trying to do in a very concise thing. So it's one line, although list comprehensions, as you get more complex, people will, or as the variable names get longer, people will break them onto multiple lines. So the, for node nodes, all right. So, you know, you'll have stuff that's multiple lines. It's the single line thing is not a natural advantage. It can, there's almost this kind of idea that single lines are good. Single lines can be good. If you played around with any Unix shell scripting, you'll notice that sometimes people go really insane with single line kind of things. They do amazing work, but oh dear gods, I can't understand them. But they, at least if I recognize it's a list comprehension here, I know what I'm getting in for. There's a limit to how much power you can stack into this, right? Now, in terms of the power here, we'll just quickly go back to this thing. I did mention that the expression was, well, we've gone into this where we've said we have a list of things and we can reduce it. So we can shrink it down. We can knock out items and throw them away. Great. You're probably wondering, what is expression? So an expression is, I don't know the formal definition for it off the top of my head, but I believe it is a statement that can return or that will return a value. So x equals, that is not an expression. That is an assignment statement. So it's saying x equals 3. This is an expression. It's an equality test. X equals 3. It can return you the value. Oh, wait. X isn't fine. Whatever. It can return you a value. true or false. Whereas if we said x equals 3, it doesn't return you anything. It just says you're done. Sure. Right, so there's a difference there. Expressions can be used in our purpose. We can use expressions to find out something about this. So we'll do the simple version with, we'll just double the number. Double. Right. So an expression can be, I want my new list to be the original value times 2. So 20, 28, 36. You would think I've memorized these by now since I've done it 3 times, but I haven't. I'm doing this on the fly. 66. Right, cool. Doubling them. Now, let's say we want to combine these two and we just say we want to double the big numbers. Okay, cool. Double big. All right. Not big, not big, not big, is big. 182 is big. Oops. Not big and is big. All right, so that's our end result. We want this thing here. So let's just write these out. Let's do all of them actually. Big num equals x for x in numbers if x is greater than 30. All right, that's the big num thing. Double equals x times 2. So that's our expression. 2 lots of x multiplied by 2. All right, so we didn't have any conditions. We just multiplied everything by 2. Double big is, as you'd guess, it's a combination of the two. X times 2 for x in numbers if x is greater than 30. Right, and that's literally what it'll do. So let's run that. Those are the numbers. According to this, big num is that, double is that, double big is that. So my mental maths was good. Yes. But you'll also see there's a particular ordering to it, and it's actually read left to right. So you apply this expression for everything in this list here if the condition is true. So you filter it first, so you just toss out any junk you don't want, and then you do some work to what's left over. So it's this kind of progression we had here. You have your original numbers or your original list, you filter it, and then you whatever's left, then you can apply the doubling to, right? So let's zoot back over here. I'll clean this up, and we'll apply the same idea of finding out something about items in your list to in Nuke. So let's throw down a couple of transform nodes here. So I've got 5 of them. I'm going to pick the ones that are even numbered, just they're easy to see, and I'm going to modify the shutter on them. So let's say you've got a shot and you're playing around with it and you're just jamming away, and suddenly you're told that, oh, we've updated the default shutter, or you know, stop doing that because we're finding that's all buzzy a little bit. So here for our node selection, let's go back here. Let's get some more space. So we can initially do the filtering thing. So actually, I know what we're going to do. Let's stack a bunch of these operations together. Right. So we have our nodes. So the first thing we want to do is we want to transform and only get the we want to filter it down to only the transform nodes. You're probably saying that in your head as I wrote it. Literally, give me thing for thing in the nodes if the thing is a transform. Done. There we go. Just got the transforms. Next thing we want to do is we can filter these transforms down to the odd shutter. Equals, same pattern again. Whoa. Oh, I hit space in the wrong window. Oops. My bad. X for X in nodes, the same starting pattern if and our condition is different this time. If the shutter value doesn't equal the default of 0.5. So, oops, X dot shutter. There we go. All right. All right, there you go. So we've taken the nodes, we've reduced the list down to only the transforms, and we should actually operate only on the transforms. Oops. So here we have transform 4 and transform 2. So that's the filtering operation done several times. You can actually, you could combine this in one line as well. So let's just do the combination. If x shutter value is 0.5 and x dot class equals transform, right? And this will actually fail because you need it. Actually, let me demonstrate this one. So in nodes, right. So this blows up because the knob shutter doesn't exist, because we're actually testing, we're checking the shutter value on a grade, doesn't exist. We're checking on a dot, doesn't exist. Okay, so first reaction is change the order around. Alright, so that works. You can get a bit nuts with this kind of filtering here. There are other ways to approach this. If you find yourself doing anything super complex here, I would almost suggest writing a function that applies your complex filter. This kind of structure is good for very really simple things and things that adhere to the idea of it's a fairly lightweight operation. It's mentally non-taxing. So as you get longer and longer stuff here, consider writing a function or consider doing it in a more complex fashion. But go back to here. You can also stack them up this way to make it more clearer. I've got all my nodes, I've got the transforms, and for the transforms, I've checked the shutter. So you can build it up that way. There are reasons of efficiency to do A versus B, but at the level that we generally work at, efficiency is something you care about, but you want to express things cleanly and algorithmically beautifully that make sense. Basically, once you get past that line and you're starting to optimize your if you start looking at premature optimization at this level that I'm pitching some of these videos at, you can go down a rabbit hole. It's a lot of fun, but probably more important is to look at the way you approach problems, the thinking process, and just the general, like the concepts you're putting down in code. So yeah, that's a bit more of the philosophy angle, I guess. Anyway, let's get going. So last thing with odd shutter, we've filtered it down, and you can now do some other stuff. So let's change this to an expression. We want to actually find the shutter, the value. So let's see what this gives us. So this expression here, or this way we've expressed it, has basically given us a result that tells us what the odd shutter values are. So we've said, take all our nodes, get the transforms, find the ones that have an odd shutter. That's redundant, sorry. Right, and give us that. Give us the shutter values. Obviously, you can see that you can combine them as that one line. So that's the expression. That's this thing we had here, filter an expression. So we've got rid of everything that doesn't have this odd shutter, and then we've just found it out. So that's one thing we can do. The other thing you could do is look at the full name. All right. So now this expression here we've put together is saying which nodes have the odd shutter values. Transform 4 and transform 2. So in both cases, we've actually found something out about the node. Now there's a third form here we can apply, which is the form I'd say, please don't do. Or do it if you know why you're doing it. Set value to be true. Cool. You could do that as well, which will disable the nodes, right? Now, the reason I'm saying this is fine, this is fine, everything up here is fine, this is not fine, is because this is, to me, this is slightly odd. You're doing something which is not in the spirit of what I'm expecting to see with a list comprehension. you're making the, like, to make it super obvious, let's break this down. It's not the filter aspect that's the problem. It's the expression that's the problem. Right. So in odd shutter nodes. All right, so I'm going to break this into two things. So the first one is the filter operation, where we've just said, what are the odd shutter nodes? And the second one is doing something with it. Right, oops, let me undisable those. Good, all right. Right, so we're disabling those shutter nodes, okay? That doesn't make sense to me because we're not finding out any information about it. The thing we care about is disabled, right? We don't even need to store the result. See how those are disabled there? I don't care about storing anything about this. This, if you see it used like this, and I have seen it done so, it's a really compact one-liner, and it does do the thing you're trying to achieve, which is disable the nodes, which are slightly weird. But it's kind of being used more as a loop. Like, you're not using it as a list comprehension here, you're using it as a loop, and you're relying on the fact it goes through each of them. You're running an expression here. This is an expression because it returns a true false value. You can actually see here, it tells you whether or not it was able to disable them or not. So if we run it once, the second run, false, false. So the way the call's running, it's telling you, could I set that knob to that value? If it's already disabled, it can't disable it again, right? But you kind of care more about the fact you changed the knob rather than reporting something about the node. I'll use an analogy for why I find this strange. So every comper worth their salt will know about transform concatenation. So if I plug these two in here, if I set this to be scale 20 and rotate minus 64, I'll just copy that again. So this, if I invert the transform here, this will basically be do nothing, right? It'll concatenate the transforms, the matrices will be smashed together and we'll get no effect. Great. If I put an impulse filter here, cool, cubic impulse, it will only do the impulse filter at the end. Why you'd use impulse filter? Maybe you got a reason. Right? So again, not a strange thing at all. If I did this, most people would go immediately, ooh, you didn't want to do that, did you? You must have just been jamming away, you did your transform, you graded it because you were waiting for some notes, and then you got the look you like, and oh, you did another reposition here, or something of that nature. Because obviously we're degrading the image. Like, you're getting 2 filter hits when doing this would give you 1 filter hit, or in this case, no effect. But it's entirely possible, I haven't seen this, but it's entirely possible someone might be wanting to deliberately do that because they're wanting to take advantage of the fact there is this filtering of the image. I'm having trouble even coming up with this scenario because it's so contrived. But if you saw it, that's how I feel about this scenario here. It's somewhat, it's a bit less contrived. I'd see that and just go, but why? Why would you do that? Why would you not have a loop? And my logic brain would start spinning to one of these other scenarios like, oh, did you manage to actually stuff up? Did you manage to say that? And did you actually want to do this? Did you want to find out what the value of the disabled nodes were, right? And you can sort of just go, oh, maybe that's what they wanted to do. It doesn't feel like it's correct because it's such an uncommon pattern. It's clever and it's fast, much like this thing here. That's actually, if you can only achieve if you've got a particular result that you want to achieve and you can do it this way, that's actually kind of clever. It's really neat. You may not be able to do it another way. Put sticky notes in here, put comments, put labels, explain what the hell's going on. Same with here, put comments and notes, explain what's going on. But my first reaction is, oh, someone's just accidentally broken it. Do that. True story, actually, an example of this. So we had a shot once where we were mucking around with it and just trying to final it, and you know, it got put on hold for 3 months or something. explosion plate kind of CG explodey kind of things, and it was all great. Came back, trying to find all the shot, pulled it out of the archives, so restored everything because went to tape, went to archives and came back. People worked on the shot, tried to final it, and just couldn't get it through because the notes kept coming back from the client saying, hey, can you make it more like the draft version we saw? Can you make it more like this because it's got that aggressive, punchy kind of look to it? So, turns out that actually the whole reason the comp worked and had that kind of powerful thing was because we rendered we rendered the CG explosion on 2s. Actually, no, shit, it was on 3s, right? And in the comp, we were effectively getting frame holds. So when we rendered it at higher resolution, at higher quality, you're getting higher resolution frames, but you weren't getting this steppy, juddery kind of thing, which the comp had fixed. So that's another example of where it took us. I honestly think that would have cost us almost 2 weeks of turns for that, because someone would go in, make it better, look at it, it's like, it's kind of close. I mean, the frames are all there. It must be just a resolution thing. Submit it to the client. Client is like, yeah, it's looking amazing, except it's not as aggressive as I wanted it. You looped that several times, and then I got involved and went, wait a minute, what happens if we, oh God, no. So then just deleted, or actually put in just made the curve steppy for the time offset, and it went through first time. Yeah, so that's an example of where I've seen non-standard usages of setups actually causing problems down the line because no one expects it and you sort of do something completely different. So yeah, this has been hopefully useful. The list comprehension structure is actually kind of nice. It's great to express a very straightforward concept of transforming a list from one to another. You can't add items, you can only remove them, and you can do some limited expression stuff where you can find out things about it. You would use this for kind of these cases where I've done here. If you're manipulating the node graph, you would also use it in Python for just doing the kinds of things we saw. It is somewhat weird potentially, so please, if it doesn't make any sense, chuck a note in the comments. I'll try to explain it better. I probably will ramble a bit more, but yeah, let me know how you go with this one. All right, see you later.